Hi everyone, and welcome to today's lesson where we will be comparing and ordering real numbers. Our objective is to use various methods to compare numbers, so we're going to be using different methods in this video, and many of these methods are going to be focused on how you can compare numbers without needing a calculator. So let's look at our first example. Use an inequality symbol to compare each pair of numbers. In other words, a greater than or less than symbol. One easy method for comparing numbers that doesn't always work but sometimes does is compare those numbers to 1/2. For example, if I look at 3 over 5, I know that 3 out of 5 is more than 1/2 because 3 is more than half of 5. So this is greater than 1/2. I know that 0.27 is only 27 out of 100, or another way to think of this is 27 hundredths. It is less than 1/2 or 0.5. So if this number is more than 1/2 and this number is less than 1/2, I know that 3/5 is greater than 0.27. For number 2, I have two fractions. And although I could divide 5 by 9 and change it into a decimal, and 17 divided by 30, changing that to a decimal, there's an easy way to always compare two fractions, and that's by finding their cross products. In other words, I'm going to multiply 5 times 30. So if we multiply 5 times 30, we get 150. We put that number up here with the 5. Now we want to multiply 17 times 9, which is 153. Since 150 is less than 153, I know that 5/9 is less than 17 over 30. The reason this works is that a common denominator for 9 and 30 could be found by multiplying 9 by 30. So if I multiply 9 by 30 here, I would need to multiply 5 by 30. Notice that's exactly what I did when I cross-multiplied. If I multiplied 30 by 9, I would need to multiply 17 by 9, which is exactly what I did when I cross-multiplied. So instead of needing to do common denominators, you could actually just multiply 5 times 30 and 17 times 9. Okay, let's look at a couple more examples. Notice in this example, we have the square root of 52. Now the square root of 52 is not going to be a whole number, it's going to be a decimal. Normally I would want to take that and put that on my calculator and find out what the square root of 52 actually is. However, without a calculator, I already know that 7 times 7 makes 49. So this number is really the square root of 49. Since this number is over 49, the square root of 52 is going to be a little more than 7. So the square root of 52 is greater than 7. Now let's look at number 4. Now this one might look a little trickier at first because I have a decimal here and a fraction, but I notice that my fraction is improper. So I'm going to divide 18 divided by 5, and I'm going to either turn it into a mixed number or into a decimal. Turning a number into a mixed number is fairly easy. 5 goes into 18 3 times. That would be 15, so 3 would be left over. Now I may be thinking, how am I going to compare this 0.45 repeating to this 3/5? But when I look at this, I notice that we can do the same thing we did with the first example. 0.45 is less than 1/2, so this is a little less than 3 1/2. 3 out of 5 is more than 1/2, so this one is a little more than 3 1/2. So 3.45 will be less than 3 3/5 because this one is less than 3 1/2 and this one is more than 3 1/2. Okay, so now we're going to extend that and we're going to put a group of numbers into order from smallest to largest. Okay, so now we're going to extend on what we've done, and we're going to be writing each of the numbers in order from largest to smallest. Now notice, a common tendency is to write our numbers from smallest to largest, but notice that these definitions say to start with the largest number. So as I'm looking at these numbers, I know that all negative numbers are smaller than positive numbers. So these numbers, negative 2/3 and negative 1.5, cannot be my largest number. I have the square root of 4, which is 2. I have 0.4, and I have the square root of 2. What I know is that this is 2, this would have to be less than 2, and this one is a decimal. It has a whole number of 0, so the largest number must automatically be the square root of 4, which is 2. So the square root of 4 is the largest. Now if I look at my other two positive numbers, I know that the square root of 1 is 1, and the square root of 4 is 2. So if this is the square root of 1, and 2 is the square root of 4, then the square root of 2 must lie somewhere in between 1 and 2. In fact, if we were to put square root 2 into a calculator, it would end up being 1.4. So the square root of 2 is in between 1 and 2. That means the square root of 2 is my next largest number. 0.4 is somewhere between 0 and 1, and it's just a little bit less than half. So 0.4 is my next number. Now I'm left with my two negatives. Remember, in the negative side, the numbers go in the opposite order. So negative 2/3 is actually larger than negative 1.5, because negative 2/3 would be 2/3 of a unit between 0 and negative 1, and negative 1.5 would go down 1 unit and a half of another. So negative 2/3 would come next, and negative 1.5 would be last. We have one more problem that's similar. Notice in this case we're going to write from smallest to largest. And I've also noted that we will use a calculator on this problem. So as I'm looking at these, I might want to just go ahead and put these numbers into the calculator to see what they equal. So the square root of 31, my calculator tells me that that is 5.567, and it just keeps going. Then I'm going to find the square root of 11. The square root of 11 is 3.316, and it keeps going. Then I have 5.5. For my fraction, I can divide 60 divided by 11, and that gives me 5.45 repeating, but it's negative. So it's negative 5.45 repeating. Now if I look at my numbers, I have two negative numbers. Negative 5 is smaller than negative 3. So negative 5.45 is somewhere here, and negative 3 I move up and put it there. So negative 5.45 would be my smallest number. Negative 3 would be my next smallest number. Looking at my positive numbers, 3.316 is smaller than 5.5 or 5.567, so that would come next. So I would write the square root of 11 next. When I'm looking at decimals, remember that behind this number is a 0, so 5.50 is smaller than 5.567. So 5.5 would be next. Which means my last number is 5.567, or the square root of 31. So in summary, there are several different methods that you can use for comparing numbers. First of all, you can simply look at two numbers and compare each number to 1/2. Sometimes you'll get lucky and one of them is less than 1/2 and one of them is larger than 1/2. you can find the cross product of two fractions. In other words, you can cross multiply to see which side is larger. If you have two fractions, you can change each fraction to a common denominator and then compare the numerators of the fractions. Or basically, for any number, if you change all numbers to the same form, either fractions or to decimals or decimals to fractions, then you can compare each number and figure out which one is larger and which one is smaller. Thank you for watching today's lesson on comparing and ordering real numbers.